Hello everyone and welcome back. It's been a while since I've posted a video. I'm so sorry for that. I know that I said that the Octopi series was coming up next, but I got to thinking. It's the holiday time, and with holidays comes presents, and with presents comes 3D printers, at least to the lucky ones. So there might be some people out there who are just now dipping their toes into the pool that is 3D printing. And with that, I know personally that when I first started 3D printing, it seemed a little daunting at first with all the technology and all the stuff that you need to learn and just know to use one of these things. So I figured, why not just take a second and come up with some little video to help those of you who are just now getting into the world of 3D printing. If you got a printer for Christmas, you have an awesome family, they love you a lot, and I'm really wanting to help you out in getting a quick start on this. So with that, I'm going to do this little segment that I call Joe's Quick Start Guide to 3D Printing. We're high budget here. Okay, so you just got a 3D printer. This is your first 3D printer. You know you wanted a 3D printer. You've seen videos of things being 3D printed. You've probably read tons of blogs, been on the Facebook groups. That's awesome, but actually having the printer in hand is just completely different. Now you have to actually take all of that information that you've been reading and put it into practice. The first thing I wanted to do was just a quick rundown of what is on the printer to begin with. This way we have our terminology and we can talk the same language, which is important in our community, is we're all speaking the same language. So first off, let's talk about the heated bed or build platform. That's this guy down here. The build platform can be various things on various printers. It's usually aluminum, it can be heated, it cannot be heated. They come in all shapes and sizes. It could be glass, it could be a type of material that kind of feels plasticky to the touch. All of these are build platforms, and when you talk about bed adhesion, we're talking about this. This is the print bed. Moving on, we've got the hot end setup. Now when we talk about the hot end setup, we're talking about a couple of different things. The hot end setup is comprised of a nozzle, a heater core, and a heater block, and usually some form of method to take heat away from the non-essential heated parts. So if you've got filament running through to this spot, you don't want the heat creeping up and melting the filament prematurely. So there's usually some form of cooling fan, which we call a hot end fan. So beside that, you might have another fan on this setup, which is a part cooling fan, and that helps cool parts while they're being printed. That's a whole nother video, but yeah. Anyway, so your hot end has the nozzle where the hot plastic is actually extruded from. That's the term that we use, is extruding. So you have the nozzle there, and then above the nozzle you have the heating element itself inside of a block, and that's what actually does the heating. So if for some reason your printer's not heating or isn't heating enough, or you're getting weird temperature readings there, that's the place you want to start looking at, is that block, because everything is connected to that. Past that, we go into the actual axes. So your printer might have several different configurations out there. This one particularly has a y-axis, z-axis, and x-axis, and all Cartesian printers and even Delta printers have those three axes, but they might be implemented differently, I guess I should say. So on this one, the y-axis is on the bed, so the bed moves with the y-axis. The x-axis is on this arm, so when this moves, it's moving the x-axis. And then also on this arm is the y-axis, which is your depth axis, up and down. That's on this particular printer. This is the Monoprice Mini Select, by the way. So you might have a bed or a printer that has the z-axis on the bed, and the bed rises up and down. You might have a printer that has the x-axis on the bed, and the bed moves side to side instead of forward and backward. Standard Prusa setups, you're going to see the bed on the y-axis, and you'll see the X on an arm or slide or something similar to that. Anyway, so that's the axes that we're talking about here. Just remember, Y is front back, X is side to side, Z is up and down, and you'll be good. We want to talk about another, not necessarily an access, but something that we kind of lump into the same group because it runs off of a motor, and that's the extruder. The extruder is what actually physically pushes the filament through the hot end. So on some printers you might have a setup that has a tube. This is called a Bowden setup. So it goes from the extruder, which is up here on this guy, pushes it through the Bowden setup, down and through the hot end. Others, you might have this whole setup on top of the hot end, and that's called a direct setup, no tubing. And there are all manners of schools of thought when it comes to Bowden versus direct. We're not going to get into that. I do have another video on that I can link to in the description. By the way, I'm going to go fast on a lot of this, and the description in this video is your best friend for resources. I'll have links, and I'll also go in a little more depth on what I'm going in the video. So description, your best friend. So that's the extruder. The heated bed has a heating mechanism usually if you have a heated bed. So it's usually some form of PCB, printed circuit board heated bed, so it can heat up. Past that, you have some form of print controller that is in the printer, on the printer, somewhere. It's where everything is plugging into. It's got the USB connection, and it's driving the printer. In this particular printer, it's enclosed in sheet metal, so we're not going to worry about that. In others, it might be exposed. You might be able to see it. So if you don't feel comfortable messing with that, don't. There's voltage there, and yeah. Read up, do your homework before you mess with a controller board. You'll have some form of interface, hopefully. With this guy, you have a little display screen and a knob. This is the most common setup on a 3D printer. You usually will come with some form of an LCD screen, whether it be color or monochrome, and then a jog dial with a click functionality for selection. This is for direct printing from the printer. Most printers will be able to you'll be able to print directly from the printer or from PC, Mac, whatever. So that's the basic rundown of a 3D printer. You'll have other things like spool holders, tool holders, and all manner of other little things on it depending on what model you got, so we won't go into all of that. So now that we know that, what's the next step? Well, it's time to print something. That's probably one of the first things you tried to do when you got your printer was get it set up and print maybe a test file that came with it on an SD card. That's great. You might have ran into some issues though. We'll get into the bed and all that stuff, which is one of the most important things. But first, let's talk one of the most important aspects of the entire operation, and that's the material you print with, the filament. The filament is the raw material. It's the making of life when it comes to 3D printing. If you have bad filament, you'll have bad prints. If you have the wrong filament, you'll have bad prints. You will find that there is multiple types of filament out there. There's the Holy Trinity, which is PLA, ABS, and PETG, and then there's a whole bunch of other exotic filaments out there. You'll find flexible filaments, nylon, carbon fiber, wood filament. The sky's the limit. They're always coming out with a new type of filament, and it's great, but you have to be able to master these before you can move on to the more exotic ones. Once you get printing these fairly well, and you know your printer can handle these, then more power to you. Start in on the more exotic filaments and have some fun there. So when you're choosing between ABS, PLA, PETG, you have to kind of ask yourself the question, what can my printer actually print? What is it specified to print? Now there's a lot of printers out there that say they will print PLA and ABS and PETG, but will actually stock only really print PLA. With some modification, they print ABS, and with a little more modification, they might print PETG. So what causes that huge discrepancy? The main issue there is heat. So PLA is a low melting plastic, so you can print with the most basic printer at a nice low temperature relative to the other temperatures, and not worry about getting your bed up to 100 degrees Celsius or above, not worrying about getting your hot end up to 240 degrees Celsius or above. PETG and ABS require high temps to print, where PLA requires lower temps to print. PLA can print on a non-heated bed, so if you have a non-heated bed, PLA is your best friend. PLA can print on a bed that gets up to about 50, 60 degrees for better adhesion. PLA will print on painter's tape, glue, hairspray. PLA will print at about 190 degrees to about 220 degrees through the hot end. So If you're unsure about your hot end, start with PLA. In fact, I would say start with PLA anyway. It's hard to fail when it comes to PLA unless you print it just way too hot or way too cold. PLA is, let's just consider it your training wheels for 3D printing. When you want to get started, start with PLA. There's a lot of different versions of PLA out there. You've got regular old solid colored PLA. This is Hatchbox. Hatchbox is a great brand on Amazon. I'll have some links to it below. Hatchbox was one of the first brands I started messing with, and it is just a solid brand and easy to get off Amazon. They offer PLA and ABS. And then you can start looking at some other manufacturers around. I am here in Kansas City. Down in Springfield, Missouri, there is a filament manufacturer down there called Maker Geeks, and I like to buy some of their filament because they make really good filament, and I can get it in so many different colors and variations than the normal stuff that you get off Amazon. Like this is a crystal red PLA that came in their Geek Box, which is a subscription service, which is also available to us. So PLA, great to start off with. In fact, if your printer came with a sample little bundle of filament, 99% sure they gave you PLA, just because it's hard to fail with that stuff. So let's move on to ABS. ABS, a little bit stronger than PLA, definitely a different beast when it comes to the temps. ABS needs to be warm. Your heated bed needs to be at least 100 degrees Celsius, if not 110 degrees Celsius is the recommended bed temp for that. Your hot end needs to be somewhere in the ballpark of 220 to 240 for ABS, for most ABS filaments. And it is a bear to print. ABS likes to warp. Basically what warping means is when it's on the bed and it's printing, it just slowly peels up. And that's due to the plastic cooling down a little too rapidly, pulling right off the bed. You want to avoid that. Again, there are multiple manufacturers of ABS. It is one of the top 3 most used thermoplastics for 3D printing, and Hatchbox does carry ABS. In fact, 90% plus of my ABS is Hatchbox. I found that Hatchbox prints reliably, prints beautifully. I like their colors, so Hatchbox is a good brand for that. Then that brings us to the third member of the Trinity, PETG. PETG is relatively newer than ABS and PLA, and it is gaining speed like wildfire. I mean, it's just, we're finding that PETG prints like PLA, so nice and smooth and easy, clear, and has the strength and rigidity of ABS. So it's almost like the perfect blend between the two, but PETG has to be printed hot. This guy in particular right here is the Crystal Series PETG from Maker Geeks, and they recommend about 255 for that. Now you're gonna run into problems if you have a more or less inexpensive 3D printer, because the hot end that we talked about earlier might not be adequate to handle 255 degrees Celsius. Most of the cheaper hot ends will only handle about 240 to 245 degrees before they start breaking down internally. So if you hear the term all metal hot end, we're talking about that. We're talking about a hot end that is metal from top to bottom. Your cheaper hot ends have a little piece of plastic inserted in the middle of it to help the filament guide down, and that plastic breaks down at about 240 to 245 degrees Celsius. So if you print at that temperature for a long duration of time, it gunks up, you get a jam, hot end's pretty much dead at that point. So PETG requires an all metal hot end to be successful for a long duration of time, and it is well worth it. But that gets me into the upgrade territory. If your printer doesn't have an all metal hot end, or if you're unsure, check out the manufacturer's website, check the Facebook groups, ask questions, find out if it does have an all metal hot end, if you can do PETG before you try PETG. If it doesn't have the all metal hot end, then we can worry about upgrades later, but at least that'll get you in the ballpark of what you are looking at there. So we've gone over printer terminology, we've gone over our build material. Let's talk a little bit about models. Where can I get models at? So you might have asked for a 3D printer for Christmas, knowing where you're going to get the models, knowing maybe, hey, I'm going to design them myself, do some modeling work on my own. And that's great. For those who don't have that ability yet, or are a little just wanting to just print trinkets that they find, that's awesome too. So there are several repositories for 3D models that have already been modeled, already ready to be sliced and put onto your print and go. So below I'll have the links to several websites where you can get 3D models to print. Off of the top of my head, Thingiverse and Umagine are two great resources that have just thousands upon thousands of models that you can download for free and then print on your printer. Let's talk about build surfaces real quick. Build surfaces. So, like I said, you might have aluminum, glass, some plastic here, whatever. With that, you just need to have a good build surface that works. So you're gonna find, again, just lots of different thoughts on this particular subject. Me personally, I like to use glass and Elmer's purple glue stick. It's Elmer's disappearing purple glue stick. Here's a giant one. This on top of glass and a heated bed works beautifully for just about anything I throw at it. That might not be a great option for your particular printer. Blue painter's tape works equally as well. You just have to keep an eye on it and make sure that it's not peeling up if the part starts to warp. You can use just straight glass. You can use a special type of build material like build tack that is basically a, I don't know, it's like a pad that they just print on and it just sticks. The problem being though that it's moderately expensive for those sheets, and if it sticks too good, then you have a great chance of ruining that sheet and being out that money. So for most of us, glass and glue, hairspray also works like a quick little thing of Aquanet hairspray, or blue painter's tape. But just make sure you don't print directly on top of your aluminum if you have an aluminum build plate. That's a recipe for disaster, because if you go to peel off print and it warps your plate, plate's done. Time for a new plate, or you have to bend it back and put glass on top of it. It's just better to put some kind of interference layer in between the bed and the print. With all that being said, let's talk about how to get started. For me, I like to do things all out as much as I can, as fast as I can. But I also ran into a lot of headache doing it that way, and that might not be your speed. For 3D printing, the best recommendation that I can make to you is take it slow and take it easy. You don't have to rush into building a Millennium Falcon or a giant Groot head or anything like that right off the bat. Get the basics down. Once you've got the basics down, then start scaling your models up and in complexity and size, etc. So print out little things, stay small for a while, and once you get the print quality nailed down, your first layer, what I call the layer of destiny, trademark, the layer of destiny, the first layer is the most important layer of your print. It will determine if the rest of the print is successful or not. So the more time you spend on perfecting the first layer by bed leveling and by basic slicer settings, the better. So first layer of destiny is absolutely important. Spend as much time on that as you can until you get it right. Start slow, start small, and you're already setting yourself up for good things in the future. We talk about the first layer being the most important layer. You might have these bed leveling screws, you might have auto bed leveling, whatever leveling you have, just make sure your bed is level. That is absolutely important. If you're doing auto bed leveling, test it to make sure that you're the right distance from the plate. And if you've got manual bed leveling, take the time to manually level this thing perfectly. Usually between a hot nozzle, keyword there is hot, between a hot nozzle, about 200 degrees, and a bed, and if it's a heated bed and you're going to use the heat the bed up. So with all parts heated, you want the thickness between the nozzle and the bed to be about the thickness of a business card or a little bit thinner. For ABS, thickness of a business card. For PLA, a little bit thinner than a business card, maybe a folded piece of paper, that kind of thickness in between. You just want it to scrape in between the hot nozzle and the bed. So experiment with that, adjust as needed until your first layer is absolutely perfect. If you want to see what a first layer that is perfect looks like, I will have all kinds of stuff down in the description to show you what to strive for in that area. So we've talked about the hardware, we've talked about the material. Let's talk about the third pillar in this, the software. So you're going to be using software a lot with 3D printing. Not so much in modeling unless you want to, but when it comes to 3D prints, you have to slice them. That's how the printer knows how to handle it. This is just a little CNC machine, if you want to think of it that way, that needs move commands and needs to know how much plastic to squeeze out of this little nozzle. So you need something to take a 3D model like this and tell the printer how to do this. And that's where a slicer comes in. Now, I cannot stress enough, if your manufacturer gave you a suggestion on what slicer to use that slicer, at least starting off. That is the recipe for success, at least at first. So if you get the Monoprice Mini Select and they say use Cura, which is a slicer, use Cura. They have instructions that show you how to set up Cura, and that's going to give you the best platform to be successful right off the bat. Now, as you get more comfortable with Cura and the settings inside of it, you might move on to other slicers like Slicer or Simplify 3D, which is one of the paid slicers. We can get into paid versus free slicers in another video, but all you need to know for now is a free slicer will do the job, especially if you're just getting started. Cura is a pretty powerful little slicer for free, and I still use Cura even though I have Simplify 3D. I still use Cura when I print on this little guy, just because it's so simple, it's quick, and I can get a print on the bed from a model very, very quickly. So with that, there are slicer settings you need to know about. So pay attention. Slicer settings, these are your print settings. All of this aside, you need to know how to dial your slicer in. And if I'm freaking you out right now, I apologize. It's not that big of a deal. You'll get the hang of it. So the most important settings you need to know about are layer heights, layer shells, bottom top layers, temperatures, and then maybe retraction settings. Your manufacturer should hopefully give you an idea of where to start with all of these settings, and hopefully in the retraction settings in particular. But these are some of your most important settings. Other settings include bed adhesion methods. So you have a raft, a brim, a skirt. There are support settings. So if you print something crazy like a giant full-size skull and you've got all these little overhangs, you're gonna need supports because your printer can't print in midair, so it's gotta print on something. So it builds up these little pillars to print on top of, and that's called print support. Cura has settings for that. Every slicer has settings for that. So you want to learn how to use these settings and use them well. You also want to know the tolerances of your printer. Will your printer go down to a layer height of 0.05? Well, this one might struggle with it, but I have others that can do a layer height of 0.05. 0.05 is 50 microns, and you might hear it expressed in that metric decimal value or in its actual micron value. So if you hear a layer height of 0.2, that's 200 microns, 0.25 is 250 microns, 0.1, 100 microns, and so on. That point and then number you're going to see a lot when it comes to layer height. When I tell people to start off, I tell them to start off around the 0.175 to 0.22 micron, or yeah, 0.22 layer height, which is 175 microns to 220 microns. That's a good middle of the road as far as resolution. So you don't have to worry about a really long print, because the more layers that it has to print, the longer it's going to take. And the smaller that number is, the smaller the layer height is, which means more layers for your print. Now, that's great if you want a nice looking print that has less noticeable layer lines, but it takes forever. So you need to be careful and know that if I'm building a part that's functional, I can get away with maybe a 0.2. If I'm building a piece of art that I want to be as smooth as possible, I might try bringing it down to 0.075 or 75 microns to get a better product right off the bat. Know what your printer is capable of doing. If it says that it can only go down to 0.1, You can try below 0.1, but don't be surprised if the results aren't favorable. But anyway, so that's slicers. Now, the world of slicers is complicated in a lot of areas and then simple in others. And there are tons of videos out there that show you how to use whatever slicer that you're starting off with. So I'm not going to go into each individual slicer in this video. I just wanted to point out the fact that you need to learn the slicer. Just sticking a model into your slicer and slicing it with default settings may work, but in the end you need to learn those, and that'll help you dial in and get exactly what you want going on this. But I don't know, with that, that's really all I have for this quick start guide. If you think I missed anything, please put it down in the comments below. The more information that we get for people who are just starting off in 3D printing, the better. It will greatly enhance their experience in this area and hopefully enhance their enjoyment as well, which is, let's face it, the goal for all of us in this. So that will be the end of the quick start guide. I've got the Octopi series coming up. Hopefully by the end of this year, at least one video will be released. Next year, I will be releasing a lot of stuff. I got new equipment, new audio, new video, the whole shebang-a-bang, and we're going into full production mode, and hopefully I'll have a video for you once a week next year, if not more. We went ahead and set up a Patreon, so if you like what I'm doing and you want to see more of it and help me get cooler and better stuff to play with and review, then please feel free to support me on Patreon. I know you probably hear that from a lot of YouTube creators, and I am very thankful for anyone who does support me, because that helps me feed right back into the channel, which then helps better content and more tutorials, etc. So every bit of what I get on Patreon or through Amazon affiliate links or any other thing that I do on this channel goes right back into the channel to make it better, always. If you're new to my channel, stick around, hit that subscribe button. I do giveaways and all kinds of neat tutorials and reviews, so yeah, hit the subscribe button, why not, it's free. So yeah, that's what I've got, and I look forward to talking to you all at least one more time before the year's end, and I'm really looking forward to seeing you all in the new year 2017 and just seeing where all of this goes in 2017, because right now it's amazing and I can only imagine what another year's worth of research development is going to bring us. So have a safe new year, and I'll talk to you later.